Hello, so this is attempt 8, I think, of recording this video. I'm trying to do a summary of measures of central tendencies, the measures of position, statistical and probability distributions. I've been having always problems in this video, but they are of outside nature. But there is one thing that does tend to happen. The longer I make it, the more chances we have of fucking it up. So, we're gonna do this with a definition, a comment, an example of only one of the measures, the easier one to give an example, so that we can do it fast, so I can get rid of recording this again and again and again and again. So, what are tendency measures for position or summary measures are representatives of a given statistical or probability distribution. They are numbers that are chosen to summarize a certain distribution, be it discrete or continuous, and there are many numbers that can do that part. Some of the means can do the parts, the median can do the part, the mode can do the part, etc. There are many ways of doing this, and in particularly, I might add that none of those ways are an absolute measure of a representative of a given statistical distribution, but some are better than the others depending on the context. So let's start from down up, because this last one, the means, which are in plural for a reason, because they are the most complicated, and I won't be able to give an example for them because there's a lot of stuff to talk about, particularly here. And there's less stuff to talk about as we go up. So the mode is the most frequent value of a statistical distribution, be it continuous, be it discrete. So let's take a little bit of a look of an example. Let's say that we have a distribution like this. The mode is the peak. You can have multimodal things. So let's say you have two peaks. So you have something that approaches multimodal, with the only further observation that we are only really multimodal if we have the two peaks more or less in the same height. Though can use other definitions instead of the most frequent. And you can have way more than two peaks. You can have a legitimate multimodal distribution. You can have an amodal distribution. A uniform distribution is an example that is like that. This is the distribution of any fair die, but not in continuous in the discrete realm. And modes are more useful when you have unstructured data, or when you don't have numerical values for your data. They are qualified in qualities instead of quantities. I'm gonna give an example of what I mean by this observation. At any rate, this is one of the ways you can measure representative for a statistic distribution. There's also the median, that's the value in the middle of a crescent of or decreasing list of values. This is valid both in the discrete and continuous understanding of median. There's a very slight difference between both things, but we're not covering this today because we're not talking about the medians today. Just know that it's the value in the middle, and there are ways of establishing middle and means that are certain weightings of the data set to find a good representative for it. This is very vague for a reason, because there are ways to generalize means, and there are many ways to write means actually, and each mean is useful in a different context. So this is the part that is making things go wrong, because this part of the video actually has to be a video of itself, because this is very extensive. At any rate, let's talk about an example of mode, because that's the simplest thing in here. So let's say you have an ice cream shop and you are selling your ice cream and you have many flavors and you want to see what is the mode of a distribution of flavors. So let's say you sell chocolate, vanilla, nochola, gianduja, strawberry, lemon, chocolate mint, blueberry, and pistachio, just to give examples. And respectively, you have 146 sales of chocolate, 35 of vanilla, 15 of chocolate, 40 of gianduja, 20 of strawberry, 27 of lemon, 11 of chocolate, 18 of blueberry, and 39 of pistachio. You want to know which one of those is the mode. It's the highest number, which is chocolate. And this is probably somewhat realistic, I think. At least where I live, it's somewhat realistic. And chocolate is the mode of this ice cream distribution, of this ice cream probability distribution, if you want to say like that. Another interesting example, because this is going to be relevant for medians and means, is n the sum of n d6 die with n a lot bigger than 1. If you have a large n, for instance 100 of them, you go tendentially to a Gaussian distribution. And this Gaussian distribution is actually gonna get, if we fixate the maximum and minimum in some point, this distribution in perspective, in this perspective, looking at the maximum and minimum being reparameterized each time you add another die, this distribution is going to get thinner and thinner, and it's going to go to a delta. So where the delta is centered is the mode. This is going from discrete to continuous, if you want to think like that. And in both cases, it is the most frequent value. Though when you're going to the continuous, you can use the derivative close to this point and see where the derivative is 0 to get the maximum of this Gaussian that's gonna go to a delta distribution later. But this is examples of where you would use modes. There are more mathematically relevant examples we could do, but this is just to give you a quick idea where you would use modes, for instance. At any rate, the next thing we're going to talk about, but not today, is going to be the median. Till then, bye for now.